Hello again, everyone. Thought I'd do the answers and how-to for this test. This is about properties of polygons. Okay, so first off, it says about quadrilaterals. So, Mel has three shapes, trapezium, rectangle, and rhombus, as these are. Okay, number one, write down one property that makes the trapezium the odd one out. Okay, have a look at them, have a compare of them, and see how they're different. Okay, so first of all, you could say for the trapezium that it's only got one pair of parallel sides, whereas the others, they have two pairs of parallel sides. Okay. What else could you say? You could say that this has two obtuse angles and two acute angles. Not always the case with the trapezium, but for this one, it is. What else could you say? You could say it's got exactly one line of symmetry. The others have two lines of symmetry. Lots of different things that you could say. I think that the most popular, the most common answer for that question would probably be that it's got one pair of parallel sides. Rectangle, you could say that it's got all right angles. You could say that it's got two pairs of equal sides, so these are the same, those are the same. Lots of things you could say for that one. Okay, for the rhombus, you could say that all the sides are the same. All sides are the same length. You could say that it's got. No, actually, hang on. That one's got two obtuse. That one's got two acute. That one's got two acute. Two obtuse. Okay, ignore that one for the first one. But lots of different answers there. Okay, that's question 1, 2, and 3 done. Okay, are all squares types of triangles? Explain your answer. The answer is yes. Okay, the reason is, what defines what a rectangle is? Well, the only real definition is that it's got four right angles and that it's got four sides. That's pretty much the definition of a rectangle. Okay? Four right angles and it's got four sides. Does a square conform to that? Well, yes, it does. It's got four right angles and it's got four sides. The only extra bit of information is the fact that all these sides are equal. That's it. Okay? So that's questions 1 to 4 done. Question 5. It says, find the angle P. Okay, we've got our triangle there. The angle on top is 40 degrees. These two little lines mean that it's an isosceles triangle. Okay, if it's an isosceles triangle, at the ankles, equal angles. Okay, imagine these are someone's legs. So we're going to get the 180 degrees for an angle. Take away the 40 degrees to get you 140 degrees. These are both going to be equal, so you just half that, and you're going to get 70 degrees. Okay. What we got here? So we're trying to find the rotational symmetry and the line symmetry for these shapes. Okay. So equilateral triangle, rotational symmetry. If you keep rotating the equilateral triangle, there's going to be two more occasions where it looks exactly the same. Okay, so if there are 3 total occasions where it looks exactly the same, it's going to have an order of 3 for rotational symmetry. Line symmetry, you're going to get 1 down the middle there, you're going to get 1 down the middle there, you're going to get 1 down the middle there. So that's going to be 3 as well. Okay. Isosceles triangle, if you flip it, if you turn it, if you rotate it any way, it won't look the same at all. So it's only got an order of 1 for rotational symmetry. For line symmetry, 1 line down the middle as well. Regular pentagon. If you want to rotate it, it will look the same in 5 different ways, and it's going to have 5 lines of symmetry as well. Okay, so that's that question done, and there's 1 mark for each of those. Right. Next up. So, what is the sum of interior angles of a hexagon? So, the formula for interior angles will be, let me just adjust that a sec. The formula for exterior angles, well, there isn't actually a formula. It's the same for every single shape. So for question 7, it's just 360 degrees. Sum of interior angles of a hexagon, you follow this formula, okay? That's one way you could do it, or you could do the splitting into triangles way. I'll do both with you, okay? So if you follow this method, n is the number of sides, so you do 180 times by 6 take away 2. So 180 times by 4, we get 720 degrees. If you do it this way, where you're splitting it into triangles, 1 triangle, 2 triangles, 3 and 4 triangles, okay? So that's 180, that's 180, that's 180, and that's 180 as well. Add them all together, again, you get 720 degrees. 2 different ways you can think about that one. Now, this one's quite a difficult one. This sum of interior angles in a polygon is 2520 degrees. So that means the sum, so if you follow it this way, the sum of the interior angles in a polygon is 2520. So we've got to find out what that n is. What we could do first is divide by 180. Divide by 180. Okay. Where's my calculator? So if you divide by 180 degrees, you will get, there's my calculator. So 25, be helpful if I turned it on. 2520 divided by 180 gives you 14. So number of sides, take away 2 is 14. Add the 2, we're going to get n being 16 sides. Okay. Right. 10a. What is the size of each interior and exterior angle in a regular pentagon? This is going to be quite useful for other questions. Okay. So, let's find that. There we go. Let's use this one. Right, so for a pentagon, remember 5 sides. We're going to be using the doing the exterior angle first. 360 degrees for all exterior angles altogether. Divide that by 5, we get 72 degrees for the exterior angle. There's 1 mark. Okay, if we use this, for the interior angles, what have I done? Take away 3, it is take away 2. 180 times by that, we're going to get 540 degrees. 1 mark. If you divide that by 5, you're going to get 108 degrees. That's the final mark. Okay, so there's your answers for question 10a. Okay, so final couple of questions. Now, I've accidentally rubbed this off, so I have to quickly redraw it for you. And you've got that one there. That's a terrible drawing of it, but there you go. And you've got to try and find this angle here. Okay, now remember from the last question, it said each interior angle in a pentagon. We found that to be 108 degrees. These were all 108 degrees. Okay, angles around a point add up to 360 degrees. So, get the 360 degrees, take away 3 lots of 108, take away 108, take away 108, we're going to get 36 degrees for that one there. Okay, now this one here, if you first of all find out what each interior angle is, so if you do 180 times by 6 take away 2, you get 720. Divide that by 6 angles, we're going to get 120 degrees for each one of these. Now you might notice there's an isosceles triangle there. Okay, so if we do 180 degrees, take away the 120, we get 60 degrees. If we half it, we're going to get 30 degrees for each one of those. Okay, right. Question 12. Question 12 is a blooming difficult question. So apologies for that. Okay, now, if we first of all recognise the shape it is, it's got 5 sides, so it's again a pentagon. All the interior angles add up to 540 degrees. Okay, so if we add all these together, they will equal 540 degrees. Okay, so if we were to add up all of these sides, so if we did, 5x plus 2 plus 3x plus 5 plus 5x plus 10 plus 8x plus 8 plus 4x plus 15, and put that equal to 540. That's the first thing. That looks horrendous. In fact, it is a little bit horrendous. But we could simplify it first of all. How many x's have we got? 5, 8, 13, 21, 25 x's, 2, 7, 17, 25, 40. So 25x plus 40 equals 540 degrees. Okay, take away that 40, we're going to get 25x equals 500, divide by 25, and you're going to get x equals, what was it? 20. Is it 20? Yeah, 20. So 20 degrees is x. Okay, thank you very much.